So, yeah, fast things are good. I guess everyone can agree on that. So, who am I to say that? My name's Alex. Thank you for that. I'm working on the Greenhopper team in basically in the JIRA department. And for those of you who don't know Greenhopper, it's the Agile plugin for JIRA and makes Scrum and Kanban very easy. But what I'm going to talk about today is performance tuning. And I'm going to cover four items, basically. First, why are we actually going to tune a plugin? I'll talk a bit about server-side profiling, which is the more traditional practice. I'll be talking about client-side profiling, which is a quite new thing. And I'll be talking about some performance pitfalls that we've come across in Greenhopper and that might be interesting for you to know, just to give some examples. So first of all, why are we actually going to tune a plugin? JIRA is by itself quite fast. And it's been optimized a lot. It's caching a lot. And for its own use cases, it does things really in a great speed. But if we're writing a plugin, we do that normally to bring new functionality to JIRA. So we do things with JIRA in ways that no one has ever expected. We pick up data in large amounts. We do statistics with it. And we do generally quite crazy things. So we might get into situations that no one from the JIRA team has ever envisioned that we would do with their system. So if we deliver a plugin, we want it to be fast. And we don't want it to be fast. We want to know that it's fast before we deliver it to the client and not just find out afterwards. Because slow applications are really a bad thing. You can have great functionality. If it's too slow, then it's just not fun. So what do you do on the server side for that? The best way actually to try and figure out what the performance is or to find potential performance problems is profiling. You could go and just look at the code and try to figure out yourself what is, which part is slow. Or you could try and while you develop, make things already optimal for performance. Actually, I think that's not the right approach because you should go and actually let go through your flows and profile it, and then the profiler will be telling you at which point in your code you need to check. It will tell you which methods are slow, which lines are probably running into locking situations or similar things. But profiling on the server side is not necessarily the easiest. It requires a bit of experience. Profilers bring in overhead. So while you're watching what's happening, you're actually changing the situation. And you've got to know how to look at it. And there are a lot of situations or environmental things that influence what you see in the profiling. We're talking about I/O, we're talking about garbage collection, memory situations. So you've got to have done it several times in order to read the results properly. So I don't want to discourage anyone. Actually, what I want to try and say is, and what I'm going to show you, is that setting up a profiler with JIRA and getting things running and just having a look at the performance of your system is quite easy, and it's something that every developer can do. I'm going to use JProfiler as an example. JProfiler is a commercial profiler tool. There's a lot of others out there. There are free ones, there are commercial ones. The principle is very similar from them all. So basically what you get is a hook, an agent library that you attach to the JVM. And since JIRA and every JIRA plugin runs in a Tomcat, the best way to do that is in the Catalina shell script. So what I recommend to do is to copy one of the run profiles. There are several there already. There's run, there's debug, there's whatever it is. And you copy one, you add in the profiler-specific lines, and then you're ready to go from the JIRA side. The reason why I would recommend to do this in a separate configuration is that you can't have remote debugging and profiling at the same time with most agents. So if you want to let your JIRA server run and you still want to hook up your IDE and you want to do remote debugging, then you need to get out the profiler and vice versa. So just have two setups, two options to start, and that's the way to go. It should work very similar with all the other products. Basically, you're hooking up the profiler to a JVM, and it's as long as it's a Tomcat, it works the same. So you can go for that, not only for JIRA. So now we've got our profiler running, we've got the server started, and then the easiest thing is to just start our plugin, have a look at it, and see a page. So what happens in the background is the profiler records this data and records all the calls through the stack in the JVM, and the result looks something like this. This is from JProfiler again, but it's going to be similar with every other profiling tool. What you get is kind of like a stack trace, but enriched with the information of how many calls went through which way and how long they took. And that's the important part. Like in this example, you can see that I spent 30% of my call time in Lucene. So without that knowledge, you might look through hundreds of methods to try to find whatever makes that page slow. Or you start optimizing in a completely wrong place. Here you see, okay, if I get this thing to run quickly, I already get one of the big blocks out. So the profiling results show us the slow running calls, and they show us which methods are problematic and how we got there. Because you can have a service that gets called in 10 different ways and from 10 different other methods. So you need to know how you got, which way you took, how you got there, in order to figure out why it is actually slow. Now, you've done that on your workstation probably with a JIRA instance, and you've been opening the browser and doing it yourself. That's a good thing to do, but that's not a realistic situation. And your customer is probably not going to be just having one person, but everyone hopes to reach the big businesses, and they've got like 20 or 50 concurrent users. So that's a different situation. Probably what you want to do is profile under load. You generate load. There are tools for that, like Apache JMeter, which are fairly easy to use. Basically, they just generate HTTP requests and simulate a lot of concurrent requests on a particular page. So if you want to do it seriously, you move your profiler to a separate machine, your JIRA instance with the attached profiler, and you generate load against it, and then record the results. There are some things that you've got to watch out when you do that under load, because you don't want the environment to mess up your results. So you've got to take a look at the memory, because if you run in low memory conditions, your VM starts garbage collecting, and suddenly everything goes slow, and you don't really know why. So with JConsole, which is part of the regular JVM, you can just look at the garbage collection times, you can look at the memory situation, so that's something to observe. Another thing to watch out for from the JIRA configuration are pool size limits. If you set up a standard, you get a thread pool from Tomcat of about 150 threads, which should be enough for most normal load situations. But if you exceed that and you want to say, oh, I want to see how my application does if I hit it with 200 concurrent users, then you should better crank up these values to get a more realistic output. Otherwise, you get pool contention, and again, you see slow page responses, and you can't really see why. The same goes for the database connection. Standard, I think, is 20 connections for the pool, which is fairly low. So if you want to hit it with heavy load, and especially if your plugin does a lot of database calls that are not cached, then you probably got to get a bit more of a realistic setting here as well. But so that's if you want to see it under load. So as you can see, it's really not hard. It's something that you can get set up within half an hour. And I recommend just to play with it and get a feel for it and try it out. Because it's really a good tool and helps you pinning down performance problems very much easier than if you try it by hand or if you're shooting in the blue just by reading the code. So if you've got performance problems or if you want to check out if there are any, run a profiler, check the hotspots, or see whatever takes the most time. And there can be quite some surprises in, and places that you haven't actually expected. Like we profiled some Greenhopper pages under load, and we're quite surprised to find that the largest hotspot was velocity under load. If we 50 concurrent users on it, then we suddenly get long response times inside velocity, which we wouldn't have never checked in the first place. So we've got lots of frameworks, we've got a huge stack. Profiling just really pinpoints you out to where you want to go. So server-side profiling has been around for quite a while. You'll find lots of resources on the web for that. I'll give you some links later where you can get a good start. But client-side profiling is quite a new practice. So client-side in this case means browser. We were talking about web-based applications after all. If you do anything like Swing or something, you use the same like for server-side. But client-side profiling is new because like some years ago, we didn't have that much JavaScript or that interactive UIs that would actually require us to check out if things run fast enough in the browser. So what client-side profiling is doing for us is the same for the browser, what server-side profiling does for the Java VM. We can check for slow-running JavaScripts. We can check for every other thing that makes our page load or react slowly. That can be cached expiry headers. That can be network latency. That can be too many CSS files, too many image resources, all these kind of things. So we can check not only from the server side, but also from the client side, how fast our page loads, how fast particular operations are, or if they're slow, then why. Oh, come on. There we go. The tool I would recommend for that, and I think right now that's the only one in the market that does this in a really complete way, is Dynatrace. Dynatrace runs only under Windows, which shouldn't discourage us because, as we all know, our friend Internet Explorer is one of the not so fast browsers. And if you get things quick in Internet Explorer, you can expect that they run quick everywhere else as well. So to get JIRA and Dynatrace run together is fairly easy. Considering that you might not run Windows in the first place, you install a VM, which has the additional advantage that you can have one VM for each browser version that you're trying out. Otherwise, you try to get IE7 and IE8 run in parallel in the same Windows. It doesn't work. So you can get one VM for each. Download, install Dynatrace. It's fairly easy. Since it's Windows, download, double-click, done. You open the Internet Explorer, you log into JIRA, and you check the Remember Me hook, so you don't always have to do the same. And you can directly jump to the page that you actually want to see. Then you take the URL with whatever get parameters you need, you add it to Dynatrace, and you run it. So what will happen next is Dynatrace actually opens an Internet Explorer page. It has an ActiveX plugin thing installed, so it can record the call times and gets you back. It loads the page. You can do whatever you want to see particular actions, and then it gives you back a result. This is from the Dynatrace beta. They've done quite some work for KPIs. Whoever has been working on or has been using YSlow, the Firefox plugin from Yahoo, will probably recognize this is fairly similar. Basically, it gives you a score for the website you've just been looking at. It tells you about the browser cache performance. It tells you about network latency performance. It tells you about the JavaScript performance that you've had from the scripts that run in your page load or after the actions that you've been using. And it's a starting point to give you an overview of how the tool considers it. From there, you can go and really break down into details. Now, for resources like load time for CSS or image resources or things like that, there are other tools which do that quite well. But for actually profiling into the JavaScript, that's something that's fairly neat here. So you get a view of, you can break down into hotspots. You can see in a timeline long-running scripts. And you can really get down into the methods and see how long this particular calls took. You can see the call, the stack again, how you got to that method. Again, maybe you've been using it from 20 different places. And you can see which part of the script, which function is actually running slow. So that's a good start, because if you don't have that and you try to figure out what is my browser doing, 100% load on the CPU for 2 seconds before it shows anything to the user, it gets really tricky. If you use plain JavaScript with a profiler, again, it's easier. So I think client-side profiling is a good starting point. That's how we normally go about if we either have a problem or if we want to just generally check our pages. We do a client-side profiling run. It tells us how long the page took from the server to actually load. That gives us an indication if we need to profile the server side as well. It gives us a good overview about the whole load time, if the page was fast enough for our situation. It tells us about long-running JavaScripts and all these things. So client-side profiling is a good way to look at JavaScript performance and website load times in general. And then from there, you can go down into more specific things. So the next thing, I give you some examples, because it's been all theory to now. These are actually things we did on Greenhopper to try and get performance out and optimized. First thing I'll talk about is JQL and hit collector. Everyone probably who's doing anything on JIRA knows JQL and loves it. And this is a situation that we had for statistics in Greenhopper, where we got quite an improvement. The second thing I'll talk about are CSS selectors. If you remember from Don's last presentation, he's been using that in Selenium to find through jQuery to find particular elements. So CSS selectors are a fairly convenient feature of most modern JavaScript frameworks. And but there are some performance issues with these things. And profiling is a good way to find this out. But first, I go down for JQL and hit collector. Now, JQL lets you generate, and the searchers lets you generate statistics quite easily if you just want to know how many issues for a particular, are there for a particular situation. That works extremely well if you do a few JQL queries. If you start using a lot of JQL queries, and I'm talking about, in this case, about like 40 to 50 for a page, things start taking a while. So why is that? JQL uses Lucene. Lucene runs local on the application server. So the search against Lucene is actually extremely fast. If you have a few queries, using the search count functions from JIRA are really fast. But if you run into a lot of queries, then things getting slower. And if you replace a lot of JQL queries for statistics with one hit collector, things can be improved. Why's that? The reason behind is that JIRA does permission checking on JQL. So every time you create a JQL query, JIRA does quite a lot in the background. And if you profile it, you will see these calls that are going on. And if you do a lot of JQL queries, the whole thing multiplies. And you get up to a situation where this can take like about half a second or longer on your server. So JIRA comes around with a nice class in this case that we can use for a different approach to collect statistics. It's called document hit collector. It's part of the JIRA API. And what it does is it doesn't give you back a number of issues that you wanted to for the JQL query that you fired, but it actually gives you back the Lucene documents. So from the Lucene side, that is slower, because for just counting, Lucene can use the index. For this, it has to actually load the documents. But if we can use this to evade lots of JQL queries, this thing is actually quicker. Now, from the document, we can fetch all kinds of fields that we're interested in. So what we can do with this is we can implement our custom solution and just check, is this issue resolved? Count resolved plus 1. Is this issue in status whatever? Count that field plus 1. So with such a custom statistics collector, we can get the whole data that we want, rather instead of with 40 queries, with one query and a hit collector. Now, obviously, as you see, there are Lucene classes in the API. So if you use that, make sure that you wrap it up nicely, and don't spread Lucene classes anywhere through your plugin, because you never know if that lasts forever, and it's a third-party API in this case. Yeah, as I said, the document hit collector actually loads the document. So from the Lucene side, that is slower. You have to do some custom logic. You don't just get back an int, but you have to implement your statistics counting yourself. But in return, this thing is quite an amount faster than using many JQL queries. And how much faster? I can show you here. This is from Greenhopper 5.0. The first scan, that red or slightly red line there is the server side. And as you can see, that took about nearly 3 seconds. So after we've replaced these 40 queries with one hit collector, we got this down to less than 2 seconds on the server side. So that really took off a lot of load. And that's for a single user, right? Now you think of that in a concurrent situation when you have many users. That really put the server under stress. So we got that out, and that gave us, for that particular method, a performance increase of about 50%. So far for the server side. Now, to give you an example from the client side, are the CSS selectors. Now, what you can do, for those of you who never used that, what you can do with CSS selectors is you can go into JavaScript. You can use one of the current JavaScript frameworks like Prototype or jQuery, and you can write a query string to say, give me a div which has a class named like that. So you can pick particular elements out of your DOM tree from JavaScript in a very convenient way. But there's some trouble with that, which can really impair your performance, especially if you have a large DOM tree. Especially in Internet Explorer, again, this is trouble, because Internet Explorer has no way to find native nodes by class. It can find them by ID, and it can find them by type, but not by class. So what happens is that the JavaScript frameworks actually emulate this. So they have to walk through the whole DOM tree and compare every class attribute to the search key you were entering. And that can take quite a while. Similar thing with attribute selectors. If you use like wildcards to say, give me all elements where the class contains this string, you've got the same situation. And if you use Prototype, you will get the situation that if you fire a CSS selector, Prototype extends all the DOM nodes that it gives back. That's intrinsic to Prototype, but on Internet Explorer that performs quite horribly, especially if you get a large number of DOM nodes back. There we go. So how you should not use CSS selectors, just to give you some examples. $ can be Prototype or jQuery, whatever you used. If the first example searches for all elements on the page that have a particular CSS class. Like I said, this means JavaScript has to go through the whole document tree and compare all attributes. That can take quite a while, especially if you have a large tree in the page. The second example says, give me all divs where the class attribute contains that string. Same thing here. The first call is easy. Find element by type. That gives you all the divs. That's native browser. That's fast. But then we have to iterate over all divs and check every single attribute and see if that string is included. So if you get some 100 divs back or some 1,000 divs on your page, again, you get into performance trouble. And I'm talking about seconds here, potentially in Internet Explorer, and 200-300 milliseconds even in Firefox or faster browsers. The third example says, give me a div that has the ID that I'm giving you here. That's a bad example as well. So how do we make that better? It's not hard, actually. One of the basic ideas is try to limit the scope. If you can't avoid searching for a particular class name, don't search the whole document tree. But try to get the next highest element that actually has an ID that can be found natively. So I say, don't give me all nodes that have this particular class name. But first, find me one node that has an ID, only check the subtree of that, and from that, give me all the divs, and only those which have the class name. So the first call is native, find by ID. Second call is native, find by type. And then we only have like a handful of divs that we actually have to check out the class name. So this is much, much faster. Similar with the second example, if you have to use an attribute with a wildcard, try to limit the section of the DOM tree that you actually have to search. Just find the next highest element that has an ID, or go and give one an ID, just in order to make this faster. And the third example, if you look by ID, always have an element which has an ID, so a hash symbol in jQuery, as the first element of your CSS selector, because that's a native call and that's fast. And that's fast in Internet Explorer as well. 2 or 3 slides ago, I was talking about prototype and how it extends DOM elements. So one of the problems we had in Greenhopper was that dragging issues or dragging cards was quite slow, especially in Internet Explorer. So as you can see, we have a profiling result here from the client side, and we see there a script block, which takes quite a long time. So that's an obvious target. We know, okay, this is one thing that if we can get that optimized, that makes our page load faster. So the profiler allows us to just double-click on that block, and it will break down and show us which of the functions were actually slow. So as we can see from the result, the top thing there was the prototype mechanism of expanding the nodes. What it does is it attaches like 50 methods to each DOM node that it returns. Now in our case, we didn't care. We didn't want to do any prototype-ish things on the result of the CSS selector. We just wanted to have the DOM nodes. So these calls were completely unnecessary. And that's where the profiler really kicks in, because if we would have tried to figure that out without the profiler, we would have spent ages trying to debug somehow through JavaScript and get these things. And the profiler just points this out to us directly and says, here you lose a large part of your 2 seconds. And if we can make that faster, 80-20, that's probably enough already to get the page load down to a reasonable level. So what we did, we modified prototype a little and added a function that allows us to fire a prototype CSS selector that doesn't do the extension. And we profiled it again. We can see the hotspot is gone. Things are quick. And we were happy. There's quite a lot more that you can do. These were just really 2 examples from real life that we went through tuning Greenhopper, and we find new things every day. So things you can do really depend on what kind of problems you have and what you do with the plugin. Are you fetching or calculating large amounts of data that you need to reload and recalculate every time you load your page? You can think about caching them in memory. That would be something to do. Or you can check, are you using the plugin framework properly? Plugin framework gives you web resources, and these things are really extremely useful. They set you a future cache expiry date, so your resources like JavaScript files or CSS files are staying in the browser cache, and they don't need to be requeried every time you load the page. So we save a lot of HTTP 304s, which just tell the browser, hey, it's not updated, keep the same. So the web resources do that for you. The web resources do batched mode. So what you can do if you have a really large block of JavaScript, break it up into small pieces. They're easy to manage, they're easy to code, they're easy to try out. And the web resources will actually batch these together and send them to the user in only one HTTP request. So that all happens automatically. Just make sure you use these things and use all the useful features that are offered to get these things out. And try and profile, try and put load on your pages. All this is not difficult. you can set this all up in half a day and get it running, play with it, try around. And I think that profiling and performance tuning should not be something that is done exclusively in one point in the development process. Because if you find out 2 days before you release that some of your functions are too slow, then you really have to dig into the code, and you might find that you've been doing something in non-optimal way in a particular place, and you need to do last-minute changes which you really don't like. So I think profiling and performance optimization should be something that's part of the regular development process. Do it on a Friday. Do it whenever you have time, and just play around with it, try these things out. I find it actually pretty fascinating to get an insight into which methods in the call take how much time and figure out what's behind these things. Yeah, as I said, I drop you some links to really useful resources. And if you're interested in that, follow them, have a look, and just play around with it. I think it's something that everyone can do. So yeah, make applications fast.